Hello and welcome. A new case in graphical method of solving linear programming problem, and the case is maximize z equals to 3x1 plus x2 subject to the constraints x1 plus 2x2 less than or equal to 10, x1 plus x2 less than or equal to 6, x1 minus x2 less than or equal to 2. Yes. Whenever in any of the constraint or inequality, if a variable is with negative sign, be cautious, be alert. Many or rather most of the students make mistake in this kind of inequalities or constraints. Here also it is x1 minus 2x2 less than or equal to 1. Please be careful. Try to understand everything whenever I explain the simplification of these two. And the last is x1, x2 both are greater than or equal to 0. That means they are non-negative. Now simplification part. Yes, as I prefer to explain this thing, first segregation into equality and inequality. Equality is x1 plus 2x2 equals to 10. So now we can have the 2 points to draw the lines or the line of this equality. If x1 takes value 0, it will be 2x2 equals to 10, that means x2 equals to 5. If x2 takes value 0, then x1 will be 10. Now inequality part, x1 plus 2x2 less than 10. If x1 takes value 0, then it will be 2x2 less than 10. That means x2 less than 5. And if x2 takes value 0, then it will be x1 less than 10. To determine the graph of inequality part and to shade it correctly, this part is necessary to understand. Next is x1 plus x2 less than or equal to 6. So equality part is x1 plus x2 equals to 6. And if x1 takes value 0, it is x2 equals to 6. If x2 takes value 0, it is x1 equals to 6. Inequality part will be x1 plus x2 less than 6. If x1 takes value 0, then x2 is less than 6. If x2 takes value 0, then x1 is less than 6. Now the inequality with negative sign. Be alert. x1 minus x2 equals to 2. Okay. First of all, table the same way. If x1 takes value 0, it is minus x2 equals to 2. That means x2 equals to minus 2. If x2 takes value 0, it is x1 equals to 2. Now inequality part, that is sensitive. x1 minus x2 less than 2. If x1 takes value 0, it is minus x2 less than 2. Now we change the sides of the two factors. 2 comes on this side, hence it becomes negative. The sign remains as it is. x2 goes on the another side, so it becomes positive. Now read it from right to left. x2 greater than minus 2. Understand these part carefully. Yes. x1 minus x2 less than 2. If x1 takes value 0, it is minus x2 less than 2. Now change the side of both the factors. 2 comes to left side from right hand side, so it becomes negative from positive, and minus x2 goes from left to right, it becomes positive x2. So the inequality is now minus 2 less than x2. Okay? If we read these from right to left. It is x2 greater than minus 2. Okay. Plotting and shading will be on the basis of this last step. Now if x2 takes value 0, then it will be x1 less than 2. The same thing will happen in this constraint only. X1 minus 2x2 and equality part is equal to 1. I think we have to face a fractional value. If x1 takes value 0, then it will be minus 2x2 equals to 1. That means x2 will be minus 1 by 2 or minus 0.5. If x2 takes value 0, it is x1 equals to 1. Now inequality part, x1 minus 2x2 less than 1. The similar steps, if x1 takes value 0, then minus 2x2 less than 1. Change the side of the two factors, or rather first of all simplification. Minus x2 less than 1 by 2. Now change the side. Minus x2 is going from left to right. So it becomes positive x2. Positive 1 by 2 comes from right to left. So it becomes minus 1 by 2. Now write that from, or rather read that from right to left. x2 greater than minus 1 by 2. Some will find this a longer way. But I repeat, at the time of teaching in a classroom or at any platform, we the teachers ought to consider the last benchers also. The students who face maximum difficulties in understanding, we have to take them also into consideration. Actually, our teaching style should be more suitable to them, because some students who are really clever, some students who believe them to be clever should understand, or rather may understand this in another way easily. They can go to that route, but as a teacher I should consider the weakest possible student at the time of explaining the things. If x2 takes value 0, then x1 is less than 1. Okay, now we have simplified all four constraints by segregating into equality and inequality. Now let's go for the graph. And since the values are from 1 to 10 in case of x1 and minus 0.5 to 6 in case of x2, scale of 1 or 0.5 per centimeter can be taken. I am going to draw only a sketch of the graph, because on this kind of board it is not possible for me to draw a graph accurately, but you people are using the graph paper, so you can draw the graph with utmost accuracy. Yes, x2 axis, yeah, and x1 axis. On x2 axis we have to take value, rather negative value. Okay, it is 0, it is 0.5 and 1, rather minus 1, minus half. Yes, on x axis we are going to take maximum value 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. On x2 axis, we are going to take the maximum possible value of 6. 1, 2, 3, 4, 5, 6. Okay, the first is in the first constraint, or rather simplification of first constraint, x1 10 and x2 5. This is the line of equality. Yes, and that is x1 plus 2x2 equals to 10. Now check the inequality part. x1 less than 10, 10 or less, 10 is the line or less, okay, and x2 less than 5. Less than 5 values are below the line, so shading will be below the line. Less than 10 values are inside of the line. Now second is x1 plus x2 equals to 6. Both take value 6. x1 plus x2 equals to 6. x1 less than 6, less than 6, inner side. x2 less than 6, below the line. Yes, shading will be below the line. The third is, if x1 is 0, x2 is minus 2. Sorry, because we need minus 0.5 as well as minus 2. Yes, minus half, minus 1, minus 2. Okay. For x1 equals to 0, x2 takes minus 2, and for x2 equals to 0, x1 takes positive 2. Yes, this one. So the line will be something like this. Yeah, and what about inequality? x2 greater than minus 2. Greater than minus 2 values will be above the line. Yes, okay. And x1 less than 2. Less than 2 will be in the inner side. Yes, less than 2 inside. Last number 4 is where x1 takes value 0, x2 takes value minus half or minus 0.5, and when x2 takes value 0, x1 takes value 1. So the line will be something like this. Yeah, okay, this was the equation of x1 minus x2 equals to 2. This is equation of x1 minus 2, x2 equals to 1. Okay, now what about inequality? x1 greater than 1, inside, greater than 1, and x2 greater than half, rather minus half, greater than minus half, above the line. Yes. This is, on this line, x1 is 0 and more than 0 on right hand side. This on this line, x2 is 0 and x2 more than 0 is on the upper side. The shading of this line is inside. The shading of this line is also inside. The shading of this line is below the line. The shading of this line is also below the line. So this is the common region, and that is going to be the feasible region, convex polygonal region. Okay, so we are going to shade that part only. Now first of all, let's count how many corner points, vertices are there. First is O, 0, 0. Second is A, 0, 5. Another is B, 2, 4. This is just sketch, so you cannot see the accurate coordinates at these points, but you are drawing everything on a graph paper with utmost accuracy, so you will have the exact values of each and every corner points. At B the value must be 2, 4. Yes, at C, this is C, the value is 4, 2. This is D. At D the value is 3, 1. X1 is 3, X2 is 1. You can take X and Y also. It is not compulsory to take X1, X2. I received all these problems through various students from various examination papers, and in the question papers the signs X1 and X2 have been used, so I continue to use X1 and X2. We can use X in case instead of X1 and Y instead of X2. But in case of 3 or more variables, we have to use the sign like X1, X2, X3, X4 and so on. Yes, now E. At point E, the coordinates are 1 and 0 because X2 is 0 there. O, A, B, C, D, E. Let's check what happens with the objective function. Yes, corner point, coordinates at corner points, and Z equals to 3x1 plus x2. Okay, now what is going to happen with that? Let's check. Corner point O, 0, 0, so everything is 0. Corner point A, it is 0, 5, so it is 3 into 0 plus 5, so it is 5. At B it is 2, 4. 3 into 2 plus 4. So it is 6 plus 4, 10. Yeah? It is at C. It is 4, 2. 3 into 4 plus 2. 12 plus 2, 14. At D, it is 3, 1. It is 3, 1. 3 into 3 plus 1. 9 plus 1 equals to 10. And at point E, it is 1, 0. So 3 into 1 plus 0, that is 3 plus 0 is equal to 3. And since this is the case of maximization, maximize 3x1 plus x2, the maximum value of Z is at corner point C. And the coordinates at corner point C, vertex C is 4, 2. So x1 equals to 4, x2 equals to 2, maximum Z equals to 14 is the optimal solution to the given linear programming problem. The same question is in various reference books as well as have been asked in many question papers with the objective function 2x1 plus x2. In solving that problem also the process till the graph will be same. Only in this case it must be 2x1 instead of 3. So all these will be multiplied by 2 and the value will be according to the objective function 2x1 plus x2. But we have solved this problem as maximize Z equals to 3x1 plus x2. Many times it happens, paper setters just change the objective function and keeps everything else as it is in the original question. The value of objective function only changes. That is not a bigger point, but in this problem, please be careful while simplifying the inequalities or constraints where the variable has negative sign. This is exceptional case. We needed to take negative values of the variable x2 also. I hope you enjoyed and understood this solution at its best. Thank you very much.